All right, today we're continuing on with section 5.4, looking at multiplying and dividing rationals. In a previous section, we looked at simplifying these rational fractions, and we saw that if we did have a plus or minus in our problem, we need to factor first, and that will continue through this section as well. To multiply fractions, basically is just pushing the two fractions together. You multiply across the top, so you multiply the top times the top, and you multiply across the bottom, bottom times the bottom. And then we want to simplify. Once again, to simplify, we cancel any common factors in the top and bottom, but they do have to be factors. So if you see a plus or minus in your problem, that should be your very first step, is to factor. And the only difference between multiplication and division is that dividing is multiplying by the reciprocal. So we need to flip the second fraction over, and then we follow our multiplication rules. Looking at our first example here, it's multiplication, so we don't have to flip anything. And there's no addition or subtraction, so there's no factoring that we need to do. So multiplying across the top would give me 108 x cubed. X times x squared would give us x cubed, and then y. Multiplying across the bottom, 8 times 3 would give me 24. X times x would give me x squared. And then y cubed. Since there are no pluses or minuses, you could actually cancel right from the start. We could cancel the 4 and the 8, the 3, and the 27. I like to put everything together first. I think it just keeps everything more organized. It's up to you how you solve that problem. From here, we just want to look at this as three separate fractions. Looking at just the numbers, I can simplify both of those by dividing them by 12. That would give me 9 on the top, 2 on the bottom. With the x's, 2 x's on the bottom would cancel with 2 in the top, leaving me with 1 in the top. Remember, if we are dividing, we keep our base and we subtract the exponents. Same thing with the y's. 1 y would cancel from each spot, leaving me with 2 y's in the bottom, so y squared in the bottom. And that's all we can do for that problem. In our second example, I can see lots of pluses and minuses, so the first thing I would want to do is factor each part. When I factor the top of the first one, I can factor a common factor of x out. Don't forget about your greatest common factors. And that would leave me with x plus 3. In the bottom of the first one, I would need to x factor that. Factoring is going to be very important in this section, so if you need to go back through notes, maybe do a quick Google search on factoring. But just as a refresher, factoring is going to play a big part in this and the future sections. When I x factor the bottom, I get x minus 2 times x minus 1. In our second fraction, in the top I need to x factor. That would give me x minus 2 times x plus 1. And once again, x factoring the bottom of the second would give me x plus 3, x plus 1. Now that I've factored everything, I can cancel any common factors from the top and bottom. So this x plus 1 on the bottom would cancel with this x plus 1 on the top. X minus 2's would cancel. X plus 3's would cancel. After I cancel everything out, in the top I would just have an x. And in the bottom, I would have x minus 1. If multiple parts are left, you don't actually have to multiply them together. Just put them together in that part of the fraction. Another very common mistake is that people are very tempted to cancel these x's out because they're the same on top and bottom, but the x on the bottom isn't a factor. It's x minus something. So that doesn't cancel out with anything other than another x minus 1. In our third example, very similar problem. But now we have division. So since it's division, first thing I want to do is change this to a multiplication and then flip this second fraction over. I'd keep my first fraction the same, change it to multiplication, and then my second fraction is now 2 on top, y plus 4. Now we want to treat this just like a multiplication problem. There's pluses or minuses, so the first thing you'd want to do is factor. Factoring the top of the first fraction, we can factor a greatest common factor of y squared out. That would leave me with y squared plus 5y plus 4. And actually that part can be x factored, so we would want to go ahead and do that as well. In the bottom, we can factor out a greatest common factor of 2, leaving me with y minus 2. Nothing can be factored from the second part, so we'll just bring that down. Like I said, the top of this one can be x factored, so we still have our y squared out in front. And this would factor into y plus 4 times y plus 1. Everything else in this problem stayed the same. Now that we've factored, we can go ahead and start canceling. There's a y plus 4 on the top, a y plus 4 on the bottom, 2 on the bottom, 2 on the top. So that would leave me with y squared times y plus 1 on the top. And then y minus 2 on the bottom. Again, I don't need you to multiply these together. I'd actually prefer us leaving that apart so we can see what's in each one, especially if this is part of a bigger problem, we'd want to leave it factored. So you do not need to multiply these together. We just need to make sure that we have factored everything completely so that we can see what cancels and what doesn't. Hope those examples help as you work through the worksheet and the IXLs. As always, if you have questions, please email me or create a Flipgrid video and I'll get back to you as soon as I can. Thanks, guys.